All right. We are going to give a quick summary here of problem number 3, which is uh, inequalities, simple inequalities and compound inequalities. So let's go ahead and jump in. X is greater than or equal to 4. So we want to be able to graph this on a number line and write in interval notation. And so on a number line, we usually want to include that number, 4, and then maybe a couple of other numbers for reference. Maybe one that's less than 4 and one that's greater than 4. Greater than or equal to, um, so greater than, numbers that are greater than 4 are to the right of 4. So we're going to shade to the right of 4. But then to indicate that the solution set includes the numbers that are greater than 4 or equal to 4, we usually put a closed circle, a dot, that's filled in at 4 and then shade to the right. Okay, sometimes people like to, shade by making a squiggly line or, some sort of way to shade to the right of 4. So this is how we graph greater than or equal to 4. Greater than is the shading to the right, equal to is the closed dot. Now, in interval notation, if we want to express this set of numbers as an interval rather than a graph, we could put 4 to infinity, right? And so now there's symbols that go on the ends of this interval, and we put a square bracket to indicate that we can include 4 as part of our solution set. And so the leftmost value in our interval is 4, and this goes as far right as, well, there is no furthest to the right, so we put infinity to represent that this keeps going to the right. And then we'll put a parentheses there to show that we don't actually include the rightmost value, in this case, because there is no rightmost value. Okay, so that is our interval notation. There we go. Now let's go ahead and do x is less than -2. And so one thing that you need to know is that this symbol here, the one that looks like this, is read as less than. If we put a, little line underneath, that means less than or equal to. So x is less than 2. -2. We'll have a -2, a number that's less, and a number that's greater. And so to show that the solution set includes all numbers that are less than 2, but not including -2, just the numbers that are less than 2, we put an open circle or an unshaded circle and then shade to the left. Less than is to the left, and that is our graph. And so the interval notation here, well, we can see that the interval goes to -infinity or goes forever to the left. And so we represent that by a -infinity. And then we always put a parentheses on either positive infinity or negative infinity, since you don't actually reach that number. And then it goes as far right. We can go as far as 2, but we're not actually, and it's -2, but we're not actually including -2. So we put a round parentheses to show that -2 is not actually included. Okay. One common mistake is that students will say something like, oh, well, how about if I do -infinity to negative uh, 2.1 or something like that? Saying -2.1 is a number that's somewhere in here. Let me see, here, -2.1. But you can always find a number that's closer and closer and closer, get closer and closer to -2 without actually getting to -2. And so that's why we use the number -2 in the rightmost value, but then we use the parentheses to say, no, we're not actually including -2, but we include every number as close as you want to -2 without including that endpoint itself. Okay, so that would be incorrect. All right. So next we get to the idea of compound inequalities. And compound inequalities are just inequalities that are either joined with the word or and. Okay, and so we need to understand what the words or and mean. Okay, so the example I always like to give is, um, I want something for dinner. What do I want? I want to eat pizza or I want to eat a hamburger. Okay, so pizza or a hamburger. And so when you say, if I tell my wife I want pizza or hamburger for dinner, then I will be happy or satisfied if I have uh, pizza. I go home and there's pizza, I'll be happy. Or uh, the second way that I could be satisfied is if I go home and there is a hamburger there. Because I said pizza or a hamburger, one or the other will satisfy me, but I would be extra happy if I showed up at home and there was pizza and a hamburger there waiting for me. I would be satisfied under either of these three conditions. If one of these was met, pizza or hamburger, or both. And so that's how the OR inequality works as well. The solution set to the compound inequality is the set of all numbers that satisfy either one of the inequalities or both. Okay, and so let's take a look at a picture here. Let's go ahead and graph. Um, yeah, let's take a look at the pictures separately and then we'll look them together. So x is, let's say -1, and then there's 3 here. So I'm going to graph them on separate uh, lines, and then we'll put it together. Okay, so x is less than or equal to -1. We just talked about this in the previous, something similar here in the previous problem. X is less than or equal to -1 is shading to the left of -1 and including -1. Or x is greater than 3. So there I'm going to shade to the right of 3, but not include 3 itself. And so the solution to the compound inequality, x is less than or equal to -1, or x is greater than 3, is going to be these, it can be the numbers that satisfy one of the inequalities. So the solutions could be numbers that are at -1 or to the left, or numbers that are to the right of +3. And so this last graph here is the graph of the solution to the compound inequality. This is x is less than or equal to -1. The second is x is greater than 3. The third is x is less than or equal to -1, or x is greater than 3. So that is our final solution there. And so the interval notation is going to look something like this. The shading on the left goes as far as -infinity up to -1, and we include -1, or we can choose a number from 3 to +infinity, but not including 3 itself. Anything to the right of 3 is okay, not 3 though. And so the way that we represent the word or in symbols is through this U here. This means the U means the union of the two sets. Notice that we united the two shadings together into one graph. And so that's where the union symbol comes from. It represents the word or. Okay, so there's our answer for part A and the compound inequality. Okay, very good. Now let's take a look at an example that has the word and. And is a little bit more restrictive. And I'm going to take a look at part C. X is greater than or equal to -2, and x is less than 5. Okay. So what does the word and mean? If I said, hey, I want to get home and I want to eat pizza and a hamburger, then in that case, if I wanted pizza and a hamburger, that's going to be different. Would I be satisfied with just pizza? No, I'm not going to be satisfied there. Would I be satisfied with just a hamburger? No. I would be satisfied if, if the word and is used, then I would be satisfied if I had both pizza and a hamburger. Only under this one case where these two are satisfied at the same time, the pizza and the hamburger are there, is when I would be satisfied. In the same way, this compound inequality with the and will be satisfied if both of the single inequalities are satisfied at the same time. Okay, so let's go ahead and again take a look at, we'll do it in a couple steps here. -2 and 5, -2, 5, and -2 and 5. Okay. So x is greater than or equal to -2. That would be a filled in circle, shaded to the right. X is less than +5. And so where are both of these, and it might actually help if I just shade here, the same line actually. Where are both of these inequalities satisfied? Well, that would be exactly here in between the two, right? That is where the numbers are greater than or equal to -2 and less than +5. And that shading there where I've highlighted. And so we can, in our third line here, we can write our final solution, our final graph, our simplified graph. We can write as from -2 all the way up to 5, but not including 5. Notice 5 would not satisfy the compound inequality because 5, well, it doesn't satisfy the second inequality. 5 is not less than 5. And we said that we have to satisfy both inequalities to be a solution of the compound inequality when the word is and. Okay. All right, so the interval notation here would be closed circle indicates a square bracket, -2, and then all the way up to 5, but we're not including 5, so we put a round parentheses there. Okay. All right. And just for an example here, a -3 is to the left of -2. Would that satisfy the inequality? And we would check, is -3 less than +5? Yes. But is -3 greater than or equal to -2? No. So if it didn't satisfy the first of the inequalities, then it definitely doesn't satisfy both. Therefore, -3 is not part of the solution set. And that's why -3 is um, outside of our interval notation. Okay, I will stop there. I'll do the next problems in another video. I just wanted to give a brief introduction. So take a look at the next video.